Hello, students. Today we're going to be graphing proportional relationships. Yeah, in the previous days we practiced our graphing. Now this lesson is going to be about graphing proportional relationships and finding out what's so special about them. So let's begin. Graphing proportional relationships. As you saw the previous day, and this was a little bit of a review for a lot of you guys. The coordinate plane, how the coordinate plane is broken into 4 quadrants, 1, 2, 3, 4, and it goes in counterclockwise. How this is your ordered pair. The first number is the x coordinate. The second number is the y coordinate. All right. So most of you guys had experience with this, and yesterday or the day before we learned the experience with all 4 quadrants. So let's see what's so special about graphing proportional relationships. If you go to page 160, identifying proportional relationships. Another way to determine whether 2 quantities are proportional is to graph the quantities on the coordinate plane. If the graph of the 2 quantities is a straight line through the origin, the 2 quantities are proportional. So this is your prerequisite right here. If the graph of the 2, let me get my pencil here. If the graph of the 2 quantities is a straight line, this is prerequisite number 1. Through the origin, this is prerequisite number 2. Then the 2 quantities are proportional. So you have to end up with a straight line, and the line has to start at the origin or go through the origin. Example number 1. The slowest mammal on earth is the tree sloth. It moves at a speed of 6 feet per minute. Determine whether the number of feet the sloth moves is proportional to the number of minutes it moves by graphing on the coordinate plane. Explain your reasoning. So here it says they want us to determine whether the number of feet the sloth moves is proportional to, remember this word, very important when you're doing ratios, the number of minutes it moves graphing, by graphing it on the coordinate plane. But if you take a look at step number 1 here, it says, make a table to find the number of feet walked for 1, 2, 3, 4, and 4 minutes. It says, and if you study your table here, it says on the top you have time, on the bottom you have distance. So it says, well, at 0 time, what was its distance? That would be 0. Then at 1 minute, what was its distance? 6 feet, because that was given up on the example. 6 feet per minute, that should be boxed in. So that's your starting rate. 6 feet over 1 minute. In this case, they just so happen to put it upside down. Okay, so if we see this part right here, determine whether the number of feet is proportional to the number of minutes. So if in 1 minute it walks 6 feet, in 2 minutes it should walk double. And in 3 minutes it should walk 3 times as this. So from here to here it will be multiplied times 3. So 6 times 3, that gives you 18. In this case our scale factor is 3. Okay, to graph the ordered pairs, time, distance on the coordinate plane, then connect the ordered pairs here. So here we go. In this case, if you look at the graph here, what's very important about graphing points is that you have to label your graph very, very well. And usually, not all the time, but time will always be on your x-axis. So time will be labeled, and as you can see, you have to label your axes. So along the x-axis, they're going to measure time. And along the y-axis, they're going to measure distance. Okay? So then, if we want the time, and it's in the x-axis, that means that all these can be considered x-coordinates. And all these, since they're on the y-axis, can be considered y-coordinates. So therefore, you could set up your coordinates like this. X, Y, X, Y, X, Y, X, Y. So let me write it over here so it'll be a little bit less confusing. So 0, 0 is the first one. Then 1, 6. Then 2, 6. 2, 12, I mean. Then 3, 18. Then 4 over 24. And that way you can see them better like that. But don't get confused. Just remember, whenever you identify which ones are you're going to be your x's, which ones are going to be your y's. So let's graph this. 0, 0 tells us to be at the origin. And then 1, 6, 1 to the right, 6 up. So you know that 6 is right in between 8 and 4. And then 2, 12, 2 to the right, 12 up. You can see the point right there. And then 3 to the right, 18 up. 3 to the right, 18 up. There it is. So that's right between 16 and 20. And then the last one will be 4, 24. 4 to the right, and then 24 up. Notice how the scale here, this scale went by ones, but this scale was is going by fours. The reason why it's going by fours is because we have to have enough room to fit your biggest value on the y-axis. So when you're drawing your graph, sometimes you have to make your own scale, and you have to make it, the intervals, notice how they always have to be the same. 4, 4, 4, 4, 4. You can't change your intervals from 4, then to 10, then to 12. You can't do that. They have to be equal intervals, but you can choose any numbers you want and then go by that interval. So in this case, if you put the points together, it just so happens to, if you connect them, they happen to form a straight line. And the straight line happens to start at the origin. And this is your prerequisites for something being proportional. As you can see here, right? The quantities are proportional if you end up with straight lines and they go through the origin. So in this case, you would say, yes, the quantities here are proportional because we have a straight line and the line goes straight to the origin. So that is exactly how you answer the question. You would say the quantity, let's go back to up here. Okay. The number of feet the sloth walks is proportional to the number of minutes. Okay, and then the reason why is, you should be able to know why the reason why here. So you would put, because, I think I spelled it right, because the quantities, what is it, quantities form a straight line from the origin. Okay, so this is another way. So the previous days you learned the scale factor from one fraction to another, and then you learned how to find the constant of proportionality by dividing the ratios, and then you also learned the cross product to find out if two fractions are equal. This is just another way to find out if if quantities are proportional to each other. Let's go ahead and go to page 161. In example number 2, the cost of renting video games from Games Incorporated is shown in the table. Determine whether the cost is proportional to the number of games. So here, cost, get my pencil again, let's go with blue. The cost is proportional to the number of games rented by graphing on the coordinate plane. So we're going to rent this. We're going to graph it. Now, in this case, now you see that your table is lying downward. Usually when the tables are like this, it makes it a lot easier to graph. Write the two quantities as ordered pairs. Number games per cost. Number of games over the cost. So the number of games here, we can turn these into coordinate planes. Into coordinate pairs or ordered pairs like you learned yesterday. All right? That means that the first number is going to be your x coordinate and the second number is going to be your y coordinates to make things easier to graph. The ordered pairs are 1, 3, 2, 5, 3, 7, and 4, 9. So let's go ahead and graph that. Okay? The first one is at 1, 3. If you go 1 to the right, 3 up. The next one is 2, 5. 2 to the right, 5 up. Next one is 3, 7. 3 to the right, 7 up. And then 4, 9. 4, 9. And if you connect these lines, we start at x and y equals 1, and you connect them, you happen to get another straight line. Yes, it is a straight line, but did it start at the origin or did it go through the origin? The answer here would be no, because the origin is right here, and this line started at y equals to 1. So you could put there y is equal to 1 right there, and it's supposed to start at y equals to 0. Now, for this relationship, you would say the line does not pass through the origin. Just by that part, it fails the proportionality test. So the cost of the video games is not proportional to the number of games rented. And that would be the answer for that one. So you're looking for a straight line, but that passes through the origin. And the reason we say not start at the origin is because when you have all 4 quadrants like this, right, the line can actually go straight through the origin and not actually start at the origin. Okay? All right, so that should be enough for you guys to start your got it problems here. All right, let's go to the next page. Let's do example number 3 here. It says, which batting cage represents proportional relationship between the number of pitches thrown and the cost? The graph for softball plus, here's softball plus, this is the graph for softball plus, right? Let's put SP, softball plus, is a straight line, but it does not pass through the origin. So the relationship is not proportional. So this one is non-proportional. So you put non-proportional. Okay, let's leave it alone. Non-proportional. So the graph for the fun center, this one right here, is a straight line through the origin. So this is all we need to know. A straight line through the origin, as you can see here. So this one you say that it's proportional. Okay? So non-proportional because it starts at y equals to 3. And this one is proportional because it starts at y equals to 0. And x equals to 0. Okay? So that'll be enough. Today we're gonna, when we get to class the next day, we're gonna be doing all these problems so we can actually have some fun with this. This is actually a quite fun lesson. Thank you very much.